Hello, this is Chemistry, the Central Science 11th edition. We're in Chapter 3 on stoichiometry, and we are in question number 59 in the end of the chapter questions. Several brands of antacids use aluminum hydroxide to react with stomach acid, which is primarily hydrochloric acid. So we're to do several different things here. First of all, we're going to balance the equation. In order to know, stoichiometry is amounts. If I give you this amount, how much of something else am I going to get? So it's essentially accounting. In order to do accounting, I need to know that the amounts of these elements are the same on both sides. They have to be balanced. Then the relationship between the balanced equation gives me the amounts I'm talking about. So let's do oxygen last. Usually do oxygen last. So let's do aluminum. On the left, I have 1. On the right, I have 1. Good. Let's do chlorine. On the right, I have 3. So that means I need 3 on the left. Okay. So let's do hydrogens. I have, in the aluminum hydroxide, I've got 3 H's because it's 3 in front of or after the parentheses. So it's 3 hydroxides. So 3 H's. So that's 3. And then 3 in the hydrochloric acid. So I have a total of 6 on the left. So I need 3 times 2 is 6 on the right. Okay, now let's do oxygen. On the left, I've got 3 hydroxides, so I have 3 oxygens, and on the right, I have 3 waters, so I have 3 oxygens. So this is a 1 to 3 to 1 to 3 relationship. Okay, that's how they're related. For every 1 of the first molecule, you'll have 3 of the second, and you'll produce 1 of the AlCl3 and 3 waters. Okay, so it's related in that 1 to 3 relationship. So that was A, so we balanced it. B, calculate the number of grams of HCl that can react with 0.5 grams of aluminum hydroxide. All right, so we've got 0.5 grams. I want to go to moles because remember, I need a number. Numbers make ratios. 2 is to 3 as 4 is to 6. Okay, it's related based upon mathematics, and the math is numbers to numbers. And that's what a mole is. A mole is a huge number, but it's still a number. Grams is a weight. I want to know how many of these things there are, and it's 1 to 3 relationship. Okay, so I need to know how many moles of aluminum hydroxide there are. All right, so let me pause the tape. I'm going to ask Siri what these molar masses are, because I don't feel like adding them up, and I'll be back in a second. Ding! Siri told me that water was 18 grams a mole, aluminum chloride was 133, hydrochloric acid was 36, and aluminum hydroxide was 78. So I need to use these amounts as I change from grams to moles. Remember, to go from grams into moles or moles to grams, you go through the molar mass. And the molar mass is simply every one of these elements added up, all their atomic weights added up, and you can find all of their atomic weights on the periodic table. All right, so I'm going to come over here. I'm going to say 0.5 grams of aluminum hydroxide. I find that it's 78 grams per moles. Grams cancel. I'm now in moles, so I'm going to divide. 0.5 divided by 78 gives me 0.0064 moles. Okay, that goes here, 0.0064. Now I have a number, and as a number, I can do a ratio. I'm going to say this number is to this number, as I don't know is to 3. Okay, because I want to know how many moles of the hydrochloric acid, because eventually I'm going to go to grams. They want me to find grams, so I need to find moles first. So I'm going to do a ratio. 0.0064 is to 1 as what is to x. All right, so this is a cross multiplying. X equals 3 times that. And we'll see that the number of moles here is 0.0192. moles. Okay. And now I need to go to grams. So I'm going to write it down. 0.0192 moles of HCl. So I go over to the right. HCl for every mole is 36.46. Okay. And so multiply that times 36.46. And I get at this as 0.701 grams. Okay, so 0.701 grams is B. All right, so let's erase. Okay, I think this was a 3 and this was a 3. 1 to 1 to 3 to 3. Okay. All right, I'm going to leave the others up there. C, calculate the number of grams of AlCl3. All right, so I want to go to moles first and eventually to grams. And the number of water, oh brother, moles, grams, I have to do it twice when 0.5 reacts. Okay, I should have kept this. 0.5 grams. To do it again, I'm sorry, 0.5 grams. And then this is AlOH, 78 grams per mole. Okay, this is 0.0064 moles. All right, so I now am going to do the ratio. I'm going to say 0.0064 is to 1 as x is to 1. Oh, that's easy. That's just the same. Something is to 1 as something is to 1. Okay, so this is also going to be 0.0064. Let's go ahead and do the other one. 0.0064 is to 1 as x is to 3. Okay, so you'll have to multiply that by 3. We have this as 0.0192 moles. All right, now let's go back to the AlCl3. This is 0.0064 moles of AlCl3. And the AlCl3 is 133, so for every mole, there's 133.34 grams. Moles cancel, so 0.0064 times 133.34. Okay, this gives me 0.85 grams. Let me now do the water. So I start with what we've got. This is 0.0192 moles. And water is for every mole 18.01528 grams. Moles cancel. So we have 0.0192 times 18.01528. Okay. This is 0.3. Round it up a little bit. There's a little bit of a fudge there. It's 3.458. So I'll put 3.5. All right. So we have 0.85 grams of AlCl3 and 0.35 grams of water. Okay. D, show your calculations are consistent with the law of conservation of mass. What a great question. Okay, so we have 0.7, this from B, this was B right here, 0.701 grams. So we have these two on the left, and I'll change my ink. We have these two on the right, and they should be equal to each other. All right, so 0.345 plus 0.85, okay, gives me on this, on the right side, 1.1958 grams. What is it on the left? 0.701 plus 0.5, okay, 1.201 grams. And that is daggone close for having all of the rounding that we've done, okay? Good question. This is a good question, okay? Hope you're learning.